look at number 1. To figure this out, we need to look at the ratio of the sides and see if they simplify down to the same thing. 70 over 59 does not simplify down. Then I got 91 over 78, 91 over 87. It's very obvious none of these simplify down and they're not equal. So these two triangles are not similar. In example 2, we want to correspond sides. We're going to look at the smallest side on the left triangle correspond to the smallest side on the right triangle. And then the middle length correspond to the middle length. And then the longest side correspond to the longest side. And then simplify those down and they end up to equal the same ratio. So we say these two triangles are similar. And so I have ABC. So I make that triangle similar to AKL. So triangle AKL. Okay, example 3. Again, we're going to take the shortest side and correspond to the shortest side in the other triangle. Simplify this one down. It becomes 3/4. Then the middle side to the middle length. That also simplifies down to 3/4. So we need to check one more to make sure. And it simplifies down to 3/4. So since all three ratios of the sides are the same, we can say the two triangles are congruent. Last time I looked at the lengths and I traced it on the triangle to help me figure out which side. You could also label each of your ratios with the letter that it corresponds. Notice that I always have one triangle on top, one triangle on bottom. And then I know I got K, L, M, so I went K, L, M. So I would do the same first letters in the other one. So it's A, B, C, assuming you labeled your sides correctly. So you can look at the ratios or you can look at the picture of the triangle itself. Okay, and number 4, we don't know any side lengths, so that means we're going to probably have to use angles. So I know that the two middle angles, CED and angle NEM, are also congruent because they're vertical angles. And because these lines are parallel, I know I have two sets of alternate interior angles, and they are both congruent to each other. So you can pick either one of these alternate interior angles that you like, because alternate interior angles of parallel lines are congruent. So we can prove these two similar by angle-angle similarity. Therefore, triangle EDC is congruent to triangle EMN. I mean, similar, not congruent. Okay, we're going to find the length of the missing side. Okay. And we were told these are already similar, so we don't have to check the ratios. So we get 13 over 39 is equal to x over 24. Cross multiply. Then you get 39x is equal to 312. Simplifying that, we get x is equal to 8. Personally, I prefer that you rewrite it as the length measurement if I don't give you the letter in place of the side. There's a question mark like this. We're going to do the same thing in number 6, doing the corresponding sides, simplify them down. Set up a proportion, cross multiply with our proportion. And we end up that x is equal to 11. So therefore, our length of ST is equal to 11. Notice I don't put a line over it because I'm doing the measure of that angle, that side. Okay. Number 7, we're going to do the same thing. So we got x over 6 corresponds to 8 over 6. Cross multiply. Now notice in this problem I didn't simplify the 8 over 6. You could have. If you want to simplify it down, it just makes it a little bit easier. That's more ideal when you don't have calculators, but you can always simplify whenever you want to. I'm going to skip number 8 because there was a typo in it, and we're going to go to number 9. Again, we're corresponding ratios together. The only thing different this time is we don't have x by itself, but we're still going to use our algebra that we've learned earlier in the year to simplify and get x by itself. So this time we figured out that x is equal to 6. Now notice, here's what I was talking about, that you can simplify down early and often if you like to. If I simplify these numbers down, it's a little bit easier for me to work with, and I don't get these numbers like 1,782. I get a little bit smaller numbers and it's easier to work with, but you can choose which of these two methods that you want to do. Notice that we get the answer regardless of which way you do, x equals 6. You don't have to do both ways, you get to choose which one you want. Okay, and question number 10. Do the same thing, check our corresponding sides by our similarity statement to help us figure out which sides correspond to which. Simplify it down. Now I can't simplify the first fraction, especially because I have that addition in the denominator, but the second fraction I can simplify down if I choose to, make it slightly easier to work with. And I can get this all the way down to 33 plus, over x plus 2 is equal to 3 over 1. Now I'm going to cross multiply. Notice I have to distribute that 3 to both terms, the x and the 2, and then get the x by itself. And we end up that x is 9 in this problem. On number 11, we're going to do the same thing. We're going to set our corresponding sides congruent to each other. Simplify down. And you should end up with x is equal to 11. Now we're looking at number 12, and this one has you draw the picture. So you got to think about what's happening with shadows and sun and the light and how it casts shadows. So here I have a street light, and that's and then I have a person standing 24 feet from the street light, and we know the street light is 25 feet tall. Now this person casts a shadow that is 6 feet. So we want to know how tall must the person be. There's the shadow. So these two are similar triangles because they share an angle and they're both right angles, so we can do proportions. Now notice I need to make this over the entire length of 30. Simplify down this expression. Cross multiply. Solve for x. And make sure I answer the question. So x did represent the height of the person, so that answers the question. So I could say the person is 5 feet tall. All right, number 13. We have a tower this time that casts a shower at 7 meters long. Okay, this time we don't know for sure if they are in one situation. So I'm going to choose to draw my triangle separately, but I know they have the same light at the same time, so they are going to be similar because the angle of the sun to the ground is going to be the same. So I have the tower, and it has a 7 meter long shadow, and then I have a stick that's 1.2 meters tall that has a 0.6 meter shadow. And so I'm going to set up this proportion just like we've been doing. Cross multiply. End up with that t is equal to 14. So I need to translate that, since this is a word problem, into a sentence. So I can say the tower is 14 meters high. The next 4 problems are going to be like the last worksheet we did, and we are looking at area. So first I want to make sure I'm in the same units of measurement, and then I'm going to set a ratio. Now I can choose to do small to big like I did here, or you can do big to small. Again, I'm going to simplify k if possible. And since I'm finding area, that means I need to figure out what k squared is equal to. And then I'm going to use k squared, and I'm going to set it equal to my area proportions. And again, since I did the small first, I need to do the area of the small over the area of the big. Cross multiply. Simplify our expression down. And we find A is 50. So let's translate that into our sentence. Okay, the small Christmas decoration has an area of approximately 50 centimeters cubed. Please don't forget to write your answer as a sentence and remember your units of measurement. Okay, first thing I need to check is I notice my area is in meters squared, so I need to make sure I have both of my expressions in meters. So I'm going to convert this centimeters to meters. So I know 90 centimeters is equivalent to 0.9 meters. And so when I do my corresponding ratios, I have 0.9 over 1.35. So I can get rid of my decimals by moving my decimals 2 places each, and then simplifying that fraction down. So I end up the k is 2/3. And so k squared is 4/9. So I set 4/9 equal to, now 4 or 0.9 represent the smaller object, so that's A, what I'm trying to find, over the larger dining table, which is 0.9 square meters. I'm going to cross multiply, solve for A. Now that I know that A is 0.4, I'm going to write my sentence to say that the coffee table top has an area of 0.4 meters squared. Okay, and 16 and 17 are similar, but this time we're dealing with volume. So once I find K, this time I'm going to do K cubed for my volume ratio, and I get 1/8 is equal to my area, my volume over V, cross multiply. And so the volume of the larger pipe is 64,000 cubic centimeters. Okay, so number 16. This time we're dealing with cost, but notice it's doing the same thing. Since cost is based on volume, I'm going to figure out K cubed again. So K cubed in this case would be 125 over 343. So now that I have the volume ratio, I'm going to use it, and I'm going to set it to the cost ratio, which would be 1.25 over C, the cost of the bigger statue. Solving this like we do all proportions, cross multiply and then simplify down. The cost of the larger statue is 3.43 pounds. Okay, question number 18. K is 14 over 20, which simplifies to 7 over 10. So K cubed, since we're dealing with volume, is 343 over 1,000. Simplifying this down, we get 343 over 1,000 is equal to V over 4,000. Cross multiply. Simplify down, we end up that V is equal to 1,370 cubic centimeters. So the smaller jar has a volume of 1,372 cubic centimeters. Okay, let's look at the luggage problem. Again, we're looking at the volume of the suitcase is proportional to the cost. So we get K is equal to 8/5, so K cubed is equal to 512 over 125. We set that equal to our cost ratio, which is 25.6 over C. Cross multiply and simplify. And we discovered that the smaller suitcase should cost 6 pounds and 25 cents. 6.25 pounds. On the last 4 problems, we have some proofs to do. Okay, first I'm going to write my given. That's a good freebie point. So always make sure you write what's given to you and put it down. Now I'm going to mark the given on my graph. And then I'm going to see what else I can figure out. Well, here I can figure out the 2 vertical angles, because we know all vertical angles are congruent. Now I have enough knowledge to say my triangle ACB is similar to triangle ECD, and we knew that by side angle side. So once we have the triangle similar, we can say that angle B is congruent to angle D by CPCTC. All right, number 21. This time I want to do the given in 2 steps, because you can choose to do it in 2 steps or in 1. So I'm going to do my first given information, mark it on my graph. Then in step 2, I'm going to do my second given information. Mark it on the graph. And then 3, let's see, what can I figure out? Well, I can figure out that NP is congruent to PN, the reflexive property of congruency. Now I have enough information to get these two triangles congruent. So triangle MNP is congruent to triangle OPN. And my reason for that is side angle side again. And then 5MP is congruent to NO, CPCTC. Now I know all these 4 proofs on this worksheet use CPCTC. Don't expect that to always occur. Okay, so let's see. I know that side line AB is parallel to DC. So what does that tell me? Well, that tells me that these two alternate interior angles are congruent. So alternate interior angles of parallel lines are congruent. Well, then I can also figure out that it was given to me that AB bisects BD. So notice here, I divided up my given. I don't have to always put the given at the very beginning. It's very common to do that, but you don't have to do it. And then I'm going to use my vertical angles. And I have these triangles congruent by angle, angle, side. I do want to note, then I have the last step by CPCTC. Now, you could have not done vertical angles. You could have done 2 alternate interior angles, and you would still have the same proof, but your reason for the 2 triangles being congruent would be angle, side, angle. So there was 2 ways to actually do this proof.